If this is the complete time period Ts, and this is the time for which it is the switch is on, this is kTs. K is the duty cycle. It is either for the 10%, 20% or 50% of the time the switch is on. So the time interval during which the switch will be on, the voltage across the diode VA is equal to Vs. VA is over here. So when this switch will be in on condition, in that case this Vs will appear across this diode, and when the switch will be off, in that case there will be no voltage across this diode. So in interval from kTs to Ts, and the voltage across the diode will be 0. In steady state, the inductor will do nothing other than the current shaping. The average voltage across the inductor is 0. Therefore, whatever this value of voltage is, this will appear across here when this switch will on. And if the average value of voltage across this inductor is 0, so the same should appear at the output. But see that the average value at output will be equal to K times Vs. K is the duty cycle. So if the duty cycle is 10%, in that case the average value of output voltage will be 10% of the input supply. If the duty cycle is 50%, in that case the output average value of voltage will be 50% of the input supply voltage. The duty cycle K can be varied between 0 and 1. Therefore, the voltage can be between 0 to Vs. If K is equal to 1, in that case the output voltage will be equal to input voltage, and for any other value V output will be less than supply voltage. This the current will this is the average value of current from the inductor. When the switch is on, the current through this inductor will linearly rise, and when the switch will off in the period from kTs to Ts, in that case the inductor will discharge, and the total ripple across this inductor is delta IL. You know that the voltage across the inductor can be shown as VL is equal to L di by dt, or VL is equal to L delta I by delta t. When the switch will be in on condition, in that case Vs will appear over here, and at this node we will have V naught. So the net voltage across this inductor will be Vs minus V naught L delta IL over kTs. This delta t is equal to kTs, because this is, we are talking about the on interval. When the switch will be on, in that case Vs will appear on this end of the inductor and V naught on this end. We have already arrived that V naught is equal to K times Vs, so we will put that value over here. So the expression is this Vs minus KVs L delta IL over KTs. This Ts has been converted into 1 over F. 1 over F is equal to T, and the rest is some simple cross multiplication. So the end result that we will get is delta IL is equal to K into 1 minus K multiplied by Vs over FL. So this equation gives us an information that the ripple across this inductor at IL and delta IL will depend on the duty cycle K, the supply voltage Vs, the frequency, switching frequency of that switch S, and the value of inductor. So it is dependent on these four factors, that is the value of inductor itself, the frequency, switching frequency, and the source voltage and the duty cycle. In order to avoid the discontinuous conduction mode, the ripple in the inductor should be less than or equal to twice the average value of the current through the inductor. Or alternatively, we can say that delta IL by half should be less than IL average. This means that the half of the ripple, delta IL by 2, it should be less than the average value of the current from the inductor, so that it does not cross the zero axis or the x-axis. That is, the current through this inductor should never become to zero. So using this condition, delta IL must be less than 2 times I naught average. The current from the inductor and the current from the output are both the same. The average value of the current from the inductor and from the output is same, because the same current is flowing from the inductor into the load during the charging and discharging time. So therefore, putting the value of delta, so we know the value of delta IL. In the previous expression, we had delta IL is equal to K into 1 minus K into Vs over FL. So the only thing is that I have only put the value of this Vs in terms of output voltage. If V naught is equal to K times Vs, so Vs is equal to V naught over K. This value is being put in place of this Vs, so the end result is something like this: 1 minus K into V naught over FL. Okay, so do not get confused over here. This is the expression that I have found in my previous slide. This is the formula for delta IL. The only thing is that I have used the value of Vs by this formula. V naught is equal to KVS, so Vs is equal to V naught over K. When I will put this value in place of this, so this K will cancel with this K, and the end result will be 1 minus K into V naught over FL. So using this value of delta IL over here, 1 minus K into V naught over FL is equal to 2 times I naught average. So from here, the value of inductance that I will get is L critical. This is the minimum value of inductance that I need to have in my circuit, so that my inductor does not go into discontinuous conduction mode.